may take some extra class. I will see your schedule and will schedule some extra classes, right, to finish the syllabus. So we in the previous class we finished this TCP implementation policy options, like what should be the TCP implementation options for different strategies, like send policy, what should be the send policy, receive policy, acknowledge policy, retransmit policy. So all those policy options we discussed. So depending on the we have seen that depending retransmit, similarly retransmit policy, where you have an option of a batch retransmission or a individual segment transmission, or so there it can be selected based on the deliver policy, based on the accept policy of the TCP. Right, acknowledgement can be a individual acknowledgement or it can be a cumulative acknowledgement. So depending on that, so we discussed as there are variety of options. So what should be the most appropriate one? So implementations may choose alternatives options, which may definitely impact performance. Right, depending on the application, basically it is being dictated based on the application which you are working on. So now the next topic is a very interesting topic, that is the basically congestion control. Right, so as we all know that the TCP is known for performing the congestion control. It is a reliable service between the two end users, like it performs end-to-end delivery with proper reliability. Reliability means without missing segments, without out of segments, like out of sequence segments. So it performs everything in a very nice manner. So how basically the congestion control is being affected? So basically, you know that the flow control strategy, you know, and in a flow control, if we talk about flow control, normally flow control scheme, which is also used for congestion control. So how the flow control scheme can be utilized or can be seen as a congestion control strategy? You remember a scenario like some segments were transmitted from the source, right? So as I told you earlier that the network conditions change abruptly. So in changing conditions, like the transit time, right? Just say suppose if I am going in a very early morning to Ranchi, I will find a less traffic. The transit time will be less, right? But if I am going at the peak hour, when the office starts or when the school timing is there, I have to, the transit time will be at the higher side, right? So, so that means what? So if the transit time is increasing in the network, that itself indicates that there is a congestion in the network. And once the transit time increases, right? And if your retransmission timer is not tuned as per that, then what will happen? The sender will get timed out and will retransmit the segments again on the network, which will further burden the network. Okay, will further congest the network, right? So it will result in a it basically happens in an exponential manner. So if the senders get timed out, they once again retransmit all those failed segments and further increases the congestion, right? So if the congestion increases on the network, the packets start dropping. Okay, so it's like an exponential increase in dropping of the packets. So how can you do that? So how can you handle it like as a simple flow control scheme? What you have to do? You have to simply control the flow that is being coming from, that is basically coming from the source. Okay, so if the source cuts down its flow, right? It generation of the segments, it can somehow be controlled. Okay, so then basically it falls into two categories. As you can see, that once when the congestion occurs, the transit time across the network increases, right? So you have to devise some mechanism to find out what exactly should be the retransmission time, because if your transit time across the network increases, okay, uh, which subsequently results in the timeout of the sender, okay, and retransmission occurs, okay, which further congests the network. So what should be the value of the retransmission timer? Okay, that plays a very vital role in handling the congestion, because if the retransmission timer value you are setting, that is in as per the current network conditions, okay, then obviously if the network is busy, okay, the network is congested, obviously the transit time will be at the higher side. So we need to keep our retransmission timer value as per that. So if we are keeping a higher side of the retransmission timer value, okay, the unnecessary retransmissions can be stopped. So that way it can help in getting relief from the congestion. So retransmission timer management is a very vital element of congestion control. Secondly, like as you know that the flow control scheme, okay, there the credit is being assigned by the receiver to the sender. So if the receiver shrinks that credit window, okay, if it doesn't give much credit to the sender, sender will not be in a position to dump the credit on the to send that much octet of data on the network. So in using these two components, right, retransmission timer management and this window management can play a vital role in managing congestion in the network. So how it is done? So how the value of a retransmission timer should be chosen? So we will discuss one by one these two issues. So see, retransmission timer value should be chosen. I told you earlier that there can be two ways. One is we should choose if we choose a static value. Static means we have chosen a fixed value. Okay, that I am choosing that it will take around 30 minutes to go to Ranchi. Okay, but if suppose there is a congestion, right, it will exceed, and it will exceed 30 minutes. The sender will get timed out. Okay, and then once again retransmission will occur. So fixed value. So if this value is too small, what will happen? मान लो आपको पता है कि रांची तक जाने में it takes 30 minutes, but if you choose 15 minutes only, okay, if you choose a very small value of transit time, right, then what will happen? If it is a small value, the sender will get timed out very soon and they will retransmit it, right? So if the value is chosen so small, it will result in unnecessary retransmissions, which will overburden the network. Secondly, if this value is chosen, if the value is large, very large, right? You know that it takes only 30 minutes to reach Ranchi, but if you have chosen 1.5 hours, right, instead of 30 minutes, so the time is too large. So then the protocol will have no significance, will have no meaning. It is because it is so unnecessary delay. It will cause unnecessary delay in the transmission of segments, right, and then delivery of the segments. So it will result in unnecessary delay, right? So if we choose a value, So window management, again, there are two ways to deal with it. One is called as a slow start mechanism. Another is called as a dynamic sizing on the window. So we will see both. First, let us see this retransmission timer management. So how it is done? See, the question arises here like, see, how will you know that? What is the network condition first? Can you say, how will you know that what is the current network condition? Then only you can select a retransmission timer value based on the current network conditions. So my question is like, how will you know that what is the current network conditions?
IGMP.
Huh?
IGMP. Routers.
IGMP.
Yes, sir.
IGMP is a group management protocol that basically takes care of the group members on different networks. Like which member is available on this network from a particular group. So that is the job of IGMP. And if you are saying ICMP, Internet Control Message Protocol, so that reports only some failures. Okay, it cannot judge the actual scenario in the network. Right? I told you two things. Like how do you judge like what exactly time is required to reach from one point to other point? How do you know that how much time you require from your home to come to VIT? How do you calculate that? Can you say how do you calculate it? Either you experience it, okay?
The timeout.
Huh?
Timeout.
Right. So so basically you have to experience it, na, that how when you are traveling by your car, how much time it takes for you to reach from your hometown to from your home to VIT, right? So first time when you came, it took you only 2 hours. And the next time you came, it took you 3 hours, right? So based on your experience, you only plan your journey. That suppose you have to catch a train from Jamshedpur, so you will plan that I have to go to Jamshedpur. It takes only 2 hours to reach Jamshedpur, right? In ideal scenario, in generally. But suppose if it is congested, so it may take 3 hours also. So based on your previous experiences, you decide that how much time you will take, right, from your place to Jamshedpur, right? So like that, similarly here also in the network conditions, like to judge the current network condition, how it is done. I told you about that time stamping is done. So once a packet is originated from the source, a time stamp is put on that packet, right? And so the packet travels in the network and reaches to the destination, right? And then from the destination side, at the destination side, the time at which at the destination, the arrival time of the packet is noted. Okay, and once again a timestamp is put. Okay, and then the packet travels from the destination towards the source. So once it reaches source, it again the arrival time at the source is noted. So in that way, we find out that how much delay is there in the network. We basically sample the network delay, like how much it is taking for a packet to move from this end to the other end of the network and coming back. So in that way, we generally find out the transit time. So suppose it may happen that sometimes when you are judging it, okay, when you are sampling the network delay, at the same time, maybe the network is not at all congested. It is completely free, right? So you noted and you find that it takes only very little time, but actually that may not be the actual scenario. That sample may not reflect you the actual scenario of the network. At the other time, when the network is congested, right, and you take a sample of the network delay, at the same time you find that the it takes a lot of time, like it takes 1 hour to reach from one end to the another end instead of 30 minutes, right? So you're sampling so when you take a sample, that is also very important, and which sample you are using it for your for the calculation of the retransmission timer management, retransmission timer, that is also very critical, right? You cannot choose only a single scenario and can decide that this will be the value of retransmission timer. So how it is to be dealt with, right? So as I told you earlier that there can be a static timer that can be either too long or too short. So that can be resulting in, if it is too long, the protocol has no meaning, and if it is too short, it will result in unnecessary retransmissions of segments, right? The second way out is we generally estimate, as I said, that we, based on the experience, that how much time it takes from one end of the network to the other end of the network, right? So we estimate the round trip delay, okay, by observing pattern of delay for recently transmitted segments. So like all the previously transmitted segment, we observe the delay observed by the previously transmitted segments, and based on that we decide on the what will be the retransmission value of the next segment. Are you following? So suppose in the past, when I have to take a decision on the nth segment, that when I have to choose the retransmission timer value of an nth segment, what I will do, I will observe the behavior, or I will observe the delay. Okay, I will estimate the delay observed by all n-1 segments, right? In deciding the round trip, in deciding the retransmission timer value of the nth segment. So generally we always choose a value greater than the estimated one. So suppose if it takes 5 seconds, so assuming that there can be a delay at the router in the processing delay, or some network conditions may change, so we always take a delta or a constant value additional along with the this round trip time value. So this can be, there can be number of conditions can result. Okay, so like you can take a simple average of over a number of segments, or you can take an exponential average using time series, or it can be a RTT, variance estimation. RTT is a basically retransmission timeout. Okay, round trip time variance estimation. Okay, so there are different algorithms. So first of all, what we need to understand is that exactly what we are going to do. We are going to decide on the retransmission timer value. So how we will decide? So we can, because the network conditions are dynamic in nature. Okay, they may change very abruptly. So how we can decide? So first of all, what we do, we learn from the experience, right? So we see the past experiences. So anything when we go, we always check that this thing is done in the past or not, right? So if it is done in the past, how far it is successful, or so similarly here also, when we are supposed to decide the retransmission timer value for the nth segment, we estimate the round trip delay observed by all n-1 segments, right? So if you choose only the immediate one, will it be okay? If you choose just immediate one, suppose if you have to decide on nth segment, and if you choose the time observed by, or the delay observed by the n-1 segment, will it be okay? Will it depict the actual picture of the network?
No, sir.
It may be or may not be, because if Maybe in the sense like if at that period of time, suppose there is no congestion, right? So there can be a true measure of time. So you can see that there is no delay. You can set as per that. Or by the time only the congestion had just started growing, does not reach to its peak, right? So it may not reflect you the actual picture of the network. So what we do, there are different ways. If you take simple average in the sense, as I told you, that for the nth segment, you take average time, like you take out the average of all the n-1 segments which you have transmitted earlier, right? How much time they have, how much delay they have observed during the transit. Okay, so you take the average of that. Okay, and then you choose the value of, like you can see here, for the k+1 segment. Okay, what we are doing, we are taking an average of round trip time for the first k segments in deciding the average round trip time for the k+1 segment, right? So we are taking an average. So will this average scheme will be fine, or will there be any issue? See, once you are saying that you have, so that means what? Suppose if you, what is the simple averaging? See, like every day someone from our institute or someone from your class visits Ranchi. Okay, you ask that fellow to write the amount of time or the time he has taken to visit Ranchi and come back, right? So from the first day of the month till the last day of the month, anyone from your class goes to Ranchi and comes back and writes this, right? And on the next month's first day, you have to go. So if you take the average of that, will it reflect the correct scenario of the time required to visit Ranchi? Like how much time it will take for you to go from BIT to Ranchi? Will it reflect you the average of all 30 days will be the actual picture?
No,
क्यों नहीं होगा बोलो?
एवरेज है तो ज्यादा भी हो सकता है, कम भी हो सकता है.
See what is important that जो बंदा मतलब तुम्हारे से जाने से एक दिन पहले गया, राइट? एक्चुअली जो वेरी रीसेंट इंसिडेंसेस हैं, ओके, वेरी रीसेंट विजिट्स हैं, ओके, दे नो मच अबाउट द करंट कंडीशंस. Okay, so they reflect more about the current conditions rather than what has happened 1 month back. Okay, so suppose if we have taken an average, right? If we have taken an average for n number of for k segments, if you see here that the segment 1 went, then 2 went, then nth went, right? So this is the nth one. Nth one is basically the most recent one. So it basically reflects the actual condition of the network, that how much time it is taken. Okay, at that time maybe whatever be the network condition, based on that it is like that, but actual most recent incidences reflect the actual condition of the network, right? So averaging mein kya ho raha hai? We are giving equal weightage to everyone. Okay, all the k incidents we are giving the actual weight, average weightage, right? Equal weightage to every transit. Okay, while actually the most recent one reflects the actual condition of the network. Are you following? So what is the meaning of it? that we should give higher weightage, right? We should give higher weightage to the most recent one as compared to the older ones, right? Then it will be justified. If we say everyone is same, okay, everything is same, then it is not going to reflect the actual condition of the network, because वो कब transmit हुआ था, right? As I told you, like somebody went out on first, okay, at that time some road construction was there, so he faced that. Then another day there was no jam, some holiday was there, so he didn't face any congestion, right? So like that, if you take what has happened on first, second, third to 1 to 28th may not reflect the actual condition of the network. Rather, what has happened on 29th, 30th, 31st, these are the most recent visits. They will tell you about the actual scenario of the congestion on the road, right? So similarly here, the most recent one should be given more preference or more weightage because they depict the network conditions more accurately, so they should be given higher weightage as compared to simply taking the average, right? Because averaging mein kya hai? We are assigning the same equal weightage to every incidence, while they do not reflect the actual conditions. Followed? What is the disadvantage of simple average?
Yes.
No. So rather than giving equal weightage to all the round trip times, okay, what we are going to do, we are going for an exponential average. So as I concluded that the most recent segments, most recently transmitted segment reflects the actual delay in the network. So they should be given higher weightage as compared to the older as compared to the segments transmitted earlier, right? So what we are doing, this is called as a smoothed round trip time estimate, SRTT, and RTO is the retransmission timer value. So SRTT is calculated, smoothed round trip time is calculated as alpha into SRTT K plus 1 minus alpha into round trip time K plus 1. So what is that? Suppose if you take the value of alpha as 0.9, okay, or 0.8 or 0.9, right? 0.8 if you take the value of alpha, so that means what? You are assigning more weightage, right? This is what RTTK plus 1, okay, average round trip time. So you are assigning more weightage to the most recently transmitted segment, okay, and less weightage to the, so 1.1 minus 0.8 is what? 0.2, right? So like that. So what is the RTO value in that case? So smooth round trip estimate is nothing but we are assigning higher weightage to the most recent transmission as compared to the older transmissions, right? So this RTO, this is retransmission timer for the K plus 1 segment, will be SRTT K plus 1 plus some delta. This is what? Some constant value. Okay, this is a constant and it is directly proportional to this SRTT. See, actually होता क्या है कि there is I hope it is clear that we want to assign more weightage to the most recent transmission rather than the older transmissions, because they actually reflect the network condition. So we have chosen this value of alpha as 0.8, so that means it reflects and calculated the retransmission timeout value plus this del. This is what? A constant. right? But actually this constant term, okay, should be proportional to SRTT. Actually ये है नहीं, this is what a constant. So if SRTT is smaller, okay, if this value is small and this value is large, okay, if this constant value is large, so then what will happen? The retransmission timer value will be higher. So actually this is what a constant. It has no link with this SRTT. So if SRTT is small, by the way, and this delta is large, then also retransmission timer value will be higher. So protocol will have no meaning, right? And if this SRTT value is high and this value is low, right, there will be more retransmissions. So how will it be done? RTO k plus 1 is calculated as minimum of upper bound, maximum of lower bound, beta into SRTT k plus 1. So what is beta? Beta is chosen between 1.3 to 2.0. So basically what you have to understand that in exponential average as compared to simple average, what we are doing in exponential average, we are assigning more weightage to the most recent transmission as compared to the older transmissions, right? So this is what RTT variation estimation, this is called as the Jacobson's algorithm. So in this algorithm, like as you know that in exponential average also, that also doesn't show the actual behavior of the network conditions, because here you are assigning the most recent transaction, most recently transmitted segments as more weightage, right? But actually the most recent one may not have showing the actual behavior of the network conditions, right? Because ऐसा भी हो सकता है like the acknowledgement got delayed just because of accumulative acknowledgement tactic of the receiver. So acknowledgement is not given by the because its buffer space is not free. So that is why the receiver has holded the acknowledgement. So actual conditions may not be reflected by the most recent transactions. So what should be the actual way? What should we do to decide the retransmission timer value? So there is the another thing, that is basically the variance estimation. RTT variance estimation. So what is the variance? Variance is basically it's a sample mean deviation. Okay, how much it is deviating from the mean, from its average value, right? So it is measured at time k. So that is what we are calculating it here. Average deviation is for k plus 1 is this. Okay, RTT k plus 1 minus ARTT k. So that is what we are calculating, the sample mean deviation measured at time k. So basically deviation means what? We are, rather than giving more weightage to the recent RTT, what we are doing? We are calculating the variance. RTT1, RTT2, RTT3. So among them, we will be calculating the variance estimation. What we are doing? We are doing the estimating the variance among the different RTT values, right? So based on that, basically we will be deciding our next retransmission timer value. So this is nothing but RTO is for k plus 1, retransmission timeout value for the k plus 1 segment will be smoothed round trip time k plus 1, right? Plus f into sdev, like sdev is basically smooth this deviation k plus 1. Okay, so so G value is given as 0.125, H is 1/4, F is 2. So I'm not going to this mathematics part, right? So what you have to understand that why we are doing it. Okay, why the exponential average is not good? Why we are going for a variance estimation? Okay, so variance estimation is required to it gives you the better reflection of the network conditions, right? So you can see from this graph, right? So this is what alpha 0.5, alpha 0.875, simple average, observed value. So you can see here that it is an increasing function. This is an average value on this side, and this is what the time. You can see with alpha 0.5, right? So you just see, and when you are increase the alpha to 0.875, right? The time is increased, right? So what does it mean? That if you remember that 1 point alpha into SRTT, so alpha and 1 minus alpha will be less, right? So here it is both same, observed value and this you see almost same, right? And this is a different one. Similarly, it can also be used as a decreasing function. So when you go for with variance estimation, you can see that when you have chosen f equal to 2 and f equal to 4, right, with f equal to 4, the average value is falling down here, right? Increasing function, and this is what about the decreasing function. So this RTT variance gives you the current scenario, gives you the correct value of the retransmitted timer value or the actual network conditions. But Jacobson's failed to answer two things: that what should be, suppose you transmitted one segment. Okay, he said that for each segment to be transmitted, the RTO value should be chosen as per that variance estimation, right? But he didn't say anything about, suppose if a segment, if the sender gets timed out and you are transmitting a retransmitted segment, then what should be the value of the retransmission timer value for a retransmitted segment? Are you following? So if you remember that CSMA-CD, rather CSMA-CD, there was an exponential back off. So whenever a collision occurs, okay, the station backs off, and every time it faces a congestion or it faces a collision, backs off for a longer period of time, right? That value is always chosen. A random value is chosen between 0 to 2 to the power k minus 1, right? R, and then the back off time is calculated. Similarly here also, so what should be the value of what should be the retransmission timer value for a retransmitted segment, right? And which RTT sample must be given as an input to the algorithm, Jacobson's algorithm? Which RTT sample should be given? So here there are two things, and two things are very, very important. So what should be the retransmission timer value for a retransmitted segment? So basically the sender gets timed out probably due to congestion, okay, or due to long round trip time, you can say because of congestion. So the same RTO, maintaining the same RTO is not a good idea. Are you following? Suppose you transmitted segment N, but there is no positive acknowledgement came from the other end. The sender gets timed out. It needs to retransmit it. Okay. So if you use the same RTO value which you used earlier for the same segment, okay, it will not be a good idea because the network is congested. So that is why you didn't get that, probably due to congestion you failed to get the acknowledgement. So we have to change the value of RTO. So what should be the value of RTO? So it is better that each time a segment is retransmitted, we need to choose an exponential backoff value for this RTO. So this is what RTO will be equal to Q into RTO. This Q is chosen, okay, depending on like the attempt. Okay, so suppose if segment failed to deliver at the first attempt, Q value is chosen as 2. Next time it will be 4, then 8, then it will be an exponential backoff, right? Binary exponential backoff. So every time this will get doubled. So for a failed segment, this RTO value will get doubled every time, right? So this is what, because using the same RTO value is not justified, because the segment could not be delivered because of congestion in the network. And if we use the same RTO value, it will again result in a failure. So we should increase this RTO value every time a segment failed to reach at the destination, or a positive acknowledgement of the segment is not delivered at the source and the source get timed out. So we need to retransmit it every time with a higher RTO value. So RTO value will increase exponentially every time. Okay, just like in CSMACD, if you remember, exponential backoff. So every time it gets advanced. Now this is about that what is this retransmitted segment RTO value. So this answer Jacobson didn't give. Jacobson only said about the segment to be transmitted. What RTO value should be there for a segment to be transmitted, but he didn't say anything about what exactly the value of RTO should be for a retransmitted segment, right? And the second thing, he didn't say in his algorithm that which RTT sample value should be given. So it's a very interesting example. What is the meaning of this? Which RTT sample must be given as an input to the algorithm? So you are giving some input to the Jacobson algorithm, like as a variance estimation. For variance estimation, what should be the value of RTO k plus 1 for the k plus 1 segment? So you are giving some input of the previous thing, right? SRTT and other things you are giving. So which sample you should give? Okay. Suppose a segment is transmitted from source A and B. This segment is transmitted from source. Okay. And this acknowledgement of this failed to reach at the source. Immediately the sender gets timed out. It retransmitted the segment. Okay, I'm not saying it failed to reach. It transmitted a segment from A to B. The acknowledgement didn't reach the sender. The sender get timed out. It retransmitted the segment with this exponential backoff. Okay, retransmitted it, and immediately it gets an acknowledgement. Okay, now this acknowledgement, if the sender believes that this is the acknowledgement, suppose I am saying I, that this is the acknowledgement of segment I, right, which was a retransmitted one, and consider it for the calculation of the RTO value for the next segment, right? Will it be okay? And are you following my question? That A transmitted a segment J. A transmitted a segment I to B, but it didn't get any acknowledgement. It gets timed out. It retransmitted a segment. Okay. and immediately it gets an acknowledgement. So if the sender believes that this is an acknowledgement of this retransmitted segment, okay, and use this as a sample, give it in the Jacobson's algorithm to calculate the RTO value. But actually, this is the acknowledgement of the actual one. It may also happen that this is the acknowledgement of the actual segment which got delayed in the network and appearing now. If it is so, then whole your calculation will be wrong. Are you following? I am again repeating. This segment got retransmitted. The sender timed out and retransmitted segment I. And immediately it gets back an acknowledgement. Right? तो अभी सेंडर क्या सोच रहा है कि ये गया था सेगमेंट और इतना जल्दी एक्नॉलेज हो गया. So if it feels that this actually represents the scenario of the network condition, while actually this is an acknowledgement of the original one. तो original के हिसाब से तो बहुत ज्यादा टाइम लगा, means network is congested, right? But the sender believes that this is an acknowledgement of the retransmitted one. Then what will happen? It will choose a smaller RTO value, and which will further result in so many retransmissions, right? And will further congest the network. On the other end, if the sender believes that this is an acknowledgement of the actual segment, while it is the acknowledgement of the original one or retransmitted one, then the situation is different. So if it believes that this is an acknowledgement of the original one and it sets the RTO value based on that, the RTO value will be too large, right? The protocol will have no meaning. Okay, it will result in an unnecessary delay in delivering the segments at the TCP at the application layer. So this also Jacobson's algorithm failed to answer this. Okay, which RTT sample must be given as an input to the algorithm? Okay, following or not?
Yes.
So all these answers were given by Karn. We have a Karn's algorithm which answered these things, right? That which sample you should use and what exactly should be done in case of a retransmitted segment. So Karn answered that we should use exponential backoff for each retransmitted segment. Okay, the RTO value should be calculated based on the backoff mechanism as we have done in CSMA CD, right? Secondly, which RTT sample should be given? So what exactly Karn has suggested that if a segment is retransmitted, ACK may be for first copy of the segment. So if you believe that this is an acknowledgement of the original one, then the longer RTT than expected. Or if you do the other thing, that's just how I explained. Okay, so what Karn has suggested, don't measure RTT for retransmitted segments. Okay, calculate backoff whenever retransmission occurs. और जब तक acknowledgement किसी segment का आ नहीं जाता, until any of the segment is positively acknowledged, till then keep using this backoff mechanism for each retransmitted segment. Use backoff RTO until acknowledgement arrives for segment that has not been retransmitted, right? So this is what the Karn has suggested to avoid this situation. So don't measure RTT for the retransmitted segments. Calculate backoff whenever the retransmission occurs, and use backoff RTO until acknowledgement arrives for segment which are not yet retransmitted, or the fresh segment, you can say. So we will do this window management in the next class. then this module will be over. So, so your quiz will be on Tuesday, right? The third quiz will be on Tuesday. Okay, then thank you.
Thank you, sir.
Tomorrow you are free sometime. I can take one extra class so that this module will be over. So we can schedule a quiz on Monday. Ayush, are you free tomorrow sometime?
Sir, Monday is a holiday.
Okay, so tomorrow can we take a class so that we can compensate that? Are you free tomorrow anytime? Or having classes?
Yes, sir, we have labs. We have 2 labs.
Okay. Okay, I will see the timetable of yours and then I will schedule some classes. Okay.